week of the cardiopulmonary system, and specifically the cardiovascular system, by talking about return of blood flow. And we've already talked a little bit about this, but now we're going to try and tie it all together. Okay, so with return of blood flow, we've got two outcomes. And so we're going to focus on that. So venous return is just how much and how fast is blood returning back to your heart. This is affected by many things, including but not limited to the amount of blood you've got, how much of the muscle pump's being used, what phase of the respiratory cycle you are in, and are the veins dilated or constricted, or in other words, how much resistance is in those veins. Now, we are an upright animal, right? Humans like to walk upright. There are problems with that because as a result, gravity tends to gravity pulls blood down towards our feet in any animal, but with us, we're relatively tall compared to our size. And so what happens is blood pools in the lower extremities, okay? And when I say pool, I want to make it very clear that it doesn't mean blood's just hanging out in your big toe, but it's just kind of moving slower, and it's more difficult to get blood back up to your heart than it is from like your brain. And so when this happens, or because of this, we have reduced venous return. Now, let's take this into account. Now let's tie this into exercise. Well, we all know that when we exercise, cardiac output needs to increase in order to maintain oxygen delivery or to increase oxygen delivery to meet metabolic demand. And we do this by trying to increase heart rate and stroke volume. However, as we've mentioned a couple of times this week, when I increase heart rate, I decrease filling time. Okay? And so what ends up happening is we need to fill the heart up with more blood in a shorter period of time. Okay, I apologize in advance for these next couple of slides, and I'm going to try and do a demonstration in class, but we have to do some math. Okay, so this is normal resting conditions. So let's just say your cardiac output is 6 liters per minute. So your heart rate's 60, your stroke volume is 100. So 60 times 100 is 6,000. That's 6,000 milliliters, so we get 6 liters. Okay, 60 beats a minute means your heart's going through a complete cardiac cycle every second. If you remember, we are in diastole for 2/3 of the time, and we are in systole for 1/3 of the time. So during diastole, we're filling the heart up, and it's not exactly this amount. It's actually less, but we're just going to say we have 7/10 of a second to fill up 100 milliliters fill your ventricle up with 100 milliliters of blood. 100 milliliters of blood is about 1/3 of a soda can. Okay, so what I challenge you to do, and you can do this while you're listening, is to just take your phone or your stopwatch that's probably on your phone and try and figure out what 7/10 of a second is. Okay, so 7 seconds is from now to now. Okay, so now to now. Okay, not a long time, but it's fair enough. Now, what you're going to do is in 3/10 of a second, you're going to eject that same 100 milliliters of blood. Okay, and so now we've cut that time in half. So 3/10 of a second is like now to now, now to now. Okay, and so I know that's hard to kind of visualize, but just to give you an idea. Okay, so 100 mils, about 4/10 of a cup. Okay, 20% of a water bottle. Like there's lots of different ways you can look at this. So this is between 1/3 of a cup and 1/2 of a cup. So now we're going to do more math, and we're going to do this during max exercise. So we're going to say cardiac output increases to 35 liters a minute. Our heart rate's 200, our stroke volume's 175. So now we're going through a complete cardiac cycle in 3/10 of a second. That was just how much time we had to contract before, but now the whole process is going to happen in 3/10 of a second. That gives us 2 seconds to add 175 milliliters to our heart. But then it gives us only 1/10 of a second to get 175 milliliters out of our heart. 175 milliliters is essentially 3/4 of a cup. Okay, I want you to fill something up, 3/4 of a cup up in 1/10 of a second. Good luck, go. Okay, so it's really difficult to do, especially when you try and wrap your head around how much 1/10 of a second is or how short it is. So how do we accomplish this? Well, first, we've already talked about it, torsion of the heart. So with torsion of the heart, and I don't think I have any slides on this, but I want to reiterate that twisting of the heart stores energy during contraction and releases that energy during relaxation when the heart's filling, and it basically creates this vortex that sucks blood into the heart. So that's one thing. The second thing is the skeletal muscle pump. Okay, this is the Go-Gurt analogy. So muscle contraction increases pressure inside your veins so that when it contracts, basically we're squeezing blood up towards our heart, which increases venous return. More muscle contraction, more blood being forced to your heart. Okay, during relaxation, that blood falls back down towards your toes, but thankfully we've got these one-way valves right here that prevent blood from going all the way back down. Okay, so just the contraction, the active skeletal muscle contraction gets blood back up to your heart. So then we've got the respiratory pump. So with inspiration, when we take a breath of air in, the diaphragm pushes down on internal organs that increases abdominal pressure, decreases thoracic pressure, so we've created a pressure gradient, and so blood is basically being forced through the veins and back to the heart. This increases venous return. So if your muscle pump during inspiration, you're getting a lot of blood back to your heart, especially that with the torsion. But this actually decreases stroke volume, okay, because blood is going to the right side of your heart and into your lungs. All right, but during expiration, the reverse is true. So diaphragm relaxes, it goes up, abdominal pressure is below thoracic pressure, and so now blood is being squeezed out of the right side of your heart and your lungs into the left side of your heart and out through your ventricle into your aorta. Okay, so we have decreased venous return during expiration, but we have increased stroke volume. Okay, and so this is one of those things. We breathe more during exercise, so we're going to help get blood in and out of our heart. We have more muscle contraction during exercise, so we're going to squeeze more blood back up towards our heart. And then our heart contracts more often and with greater force, and so that torsion of the heart is going to create a bigger pressure gradient or create a bigger suction so that we can increase stroke volume even though filling time is reduced. So, can you do these three things to end off the first week of the cardiorespiratory system?